Thank you very much, Martin. Thanks for having me. Thanks for being here. So this is about Bluetooth, or let's say advanced Bluetooth device detection, and it's called Peekabooo. So who am I? I'm a founder of the Trifinite Group. I'm professional services member of team member of the Greenbone Networks company, who is a vendor of vulnerability management solutions. And there's my own company. So, and it turns out like my whole life, my whole professional life seems to revolve around like colored body parts. It's like Bluetooth, green bone, and red eyes. We know that, right? So what is going to happen within this talk? So first I will give you a very short, very superficial Bluetooth technology overview. We're not here to talk about tech details today. This is a very low-level talk just to get people who are interested started with low effort, right? Then I will talk about Bluetooth security, like the last 20 years, maybe, like given a very superficial overview here. And then to the core of the talk, Bluetooth device discovery. At the end of the talk, I will present Project Peekaboo to you. All right. So the situation at the moment, just raise your hand if you have a Bluetooth device with you or Bluetooth enabled. So it's pretty much everybody. And who didn't turn Bluetooth on, not just for this talk, but in general? Who did it not turn on? Raise your hands. All right, so it's half of you. There's a statistics out there that I just dug up yesterday. It says 20% of all Europeans turn on their Bluetooth, usually. In the States, it's 40%, but I guess due to all this new technology coming up, like wearables, like smartwatches, people will increasingly turn their Bluetooth on, which is good and bad in a way. Well, there's worldwide 10 billion Bluetooth-enabled devices, whereas a big portion of them are smartphones. And of course, cars do have all Bluetooth. And Bluetooth, the Bluetooth SIG themselves says that audio streaming for Bluetooth is like the killer application. So everybody, or many people use Bluetooth to stream their audio from their phones to their headsets. And there's new fields of adoption coming up, so there's a lot, and we will hear about medical devices today as well. And with the advent of Bluetooth Low Energy, or what the Bluetooth SIG is calling it, like Bluetooth Smart, there's a lot of new application fields in the medical sector. And of course, there's the Internet of Things, where this new feature, mesh networking functionality, which is included in Bluetooth 5.0, and recently 5.1 got released. So there's a lot of features targeting the IoT market. So there's more to come. And as said, this is very superficial. So in the early 2000s, we had like a few profile-based attacks, some protocol-specific things. These were the things, or these were the times when the Trifinite Group, which I'm a member or founding member of, did a lot of Bluetooth security work. And of course, we were not the only ones. Later on, we had like company, Michael Osman, for example, who entered the field by SDR, sniffing Bluetooth traffic. I will mention him once more today, and also Dominic Spill and his colleague Mark. And in the early 2010s, we saw a lot of protocol attacks, but very recently we see a lot of very down-to-the-chip based attacks, which are very sophisticated and require a lot of knowledge about hardware and everything. And just to pick a few highlights, there was the Blue Born attack in 2017, which I found to be really harsh. Why is that? Because it was a buffer overflow vulnerability in the L2CAP protocol, which basically every Bluetooth Classic device is using. And it was used, or it was there in the kind of reference implementation, and everybody was vulnerable to this specific issue, which allowed code execution on the target device. And this was so, to me, where I was like away from the Bluetooth topic, this was just a shocker for me to see that this is still out there and nobody had a look at that before. So, and what we see a lot, especially with Bluetooth Low Energy, there's a lot of devices out there that implement their own kind of interface in order to talk to apps, and they're usually very poorly implemented, except you have like a brand product where the reputation loss would be damaging to the company selling this product, but usually Chinese-based manufacturers don't care a lot. So, and this all boils down to Bluetooth device discovery. So if you want to tinker with a device that is Bluetooth enabled, you would first have to find it. And back then in the old days, the Bluetooth inquiry scan just did that. You just turn on your laptop and search for devices. And usually back then, devices were all visible and all being available to you for you to connect to it. And there's even an urban legend. Who has heard about toothing? All right. So toothing was allegedly sex dating in the metro, or not metro, in the subway of London. So where people would offer their personal service via Bluetooth name, and people were just able to find each other like on a peer-to-peer fashion. So I'm not sure if this was the reason for making devices invisible by default, but this is the common standard now. So if you have a Bluetooth device, it's most likely not visible when you just turn it on. You will be able to switch it to visible once you want to pair it to another device and so on, but usually it's not visible anymore. So a lot less fun in the subway then. And researchers came up with all kinds of different methods for device discovery, but most of them are pretty costly. They need specialized hardware, or at least they're not very simple setups. Usually you would have to have a lot of knowledge about radio protocols and sniffing them and so on. So Bluetooth is not easy to sniff. But before you learn about, or we talk about Bluetooth device discovery, we have to know about that, what it's all about. And it's all about the Bluetooth device address for Bluetooth classic devices, which are like the old legacy version devices of Bluetooth. So there's 6 bytes and they look like a MAC address. And they have 6 bytes, like separated by dashes or colons. And usually the first 3 bytes of this address are assigned by the OUI table. It's like an IEEE, or I think it's IEEE. And they collect and sell these prefixes to companies who want to produce Bluetooth devices and also network devices. And a Bluetooth address is now built upon these 6 bytes, whereas the last 3 bytes are the lower address part, which are kind of half of the address already. And but these are usually assigned by the device manufacturers randomly. And the 3rd byte from the left is the so-called UAP, the upper address part. And the 2 bytes to the very left are the non-significant address parts. And we learn later on that these are really non-significant to the Bluetooth protocol. All right. So as mentioned earlier, there has been what I consider the gold standard for Bluetooth device discovery. And this is detailed in the talk from 2009. I think it was at DEF CON 17. It was called Bluetooth Smells Like Chicken. And the approach they had there was they calculated the hopping sequence. They were sniffing packets with software-defined radio solutions, like here on the right, which is the USRP, GNU Radio. Kind of USRP is address research. And of course, nowadays, there's all kinds of devices like HackRF and Ubertooth and Yardstick from Great Scott Gadgets. what they did was pretty complicated in a way that you would have to have at least some of these hardware components. And of course, you would have to understand the protocol. So the method they used was very sophisticated, and it's available on GitHub, I guess. So it's like easy to replicate it, but still you need a lot. And I thought, like 2 years ago, or 2.5 years ago, I thought there should be an easier approach to sniffing or to discovering Bluetooth devices. And because there was almost 10 years of no improvement in this field. And but the chicken method has some downsides. So the Bluetooth interface you want to discover has to be communicating. Duh. And of course, it's a very complicated setup. And it takes these people out of the equation that just want to play with Bluetooth and maybe find some other devices around in order to send them something. So this is kind of high profile. And as there's a worldwide trend going on at the moment, we see that in the USA, like everywhere in politics, there's a big dumbing down effect currently taking place. And that's why I started in the late 2016. That's when Trump was elected. I also started dumbing down stuff myself. So the goal was to find a less sophisticated, cheaper way to discover Bluetooth devices. And this is not about esoterics, sorry to say that, but it's about duality. So the core idea of discovering Bluetooth devices with Peekabooo is that usually devices share the same sock. So Wi-Fi and Bluetooth is on the same chip. That means that the OUI ID in the beginning of the device address usually is the same as for other interfaces on this device. Same vendor, same OUI prefix, right? And so knowing the Wi-Fi MAC obviously is knowing 50% of the BD device address. And then again, you have the random 3 bytes, which often have an offset from the Wi-Fi MAC, which is constant. Not all the times, but often. So knowing the offset of that Wi-Fi to MAC address, or MAC address to BD address offset, is like guessing the other 50%. And there was even a mention in a book from an old friend in 2015, Joshua Wright, co-wrote Hacking Exposed Wireless. And he's mentioning that Apple iPhones usually you have an offset of one offset in the address. So starting with this, so this was around the time where it was popular to see all the Wi-Fi probe requests and collect them. I thought, well, everybody's telling me their Wi-Fi MAC, so what can I do with that? And I tell you what I did. I went to all kinds of retailer stores and did pictures of the device next to the sign, like the vendor sign. And usually it's saying the MAC address of the Wi-Fi and the Bluetooth address. Once you have turned it on, you can see both of these addresses. I snapped pictures and added those informations to my own spreadsheet and see what I discovered. So the address offsets are, for the majority of devices, like very small. So we have, like, to the one hand, a very high offset sometimes, but you see these vendors in the middle, Huawei, Apple, Samsung. These are like, almost all of them are in this very certain area of offsets. And then again, you see the market share by manufacturers. So this shows what the major handset manufacturers are. And you can see that Samsung, Huawei, and Apple is just among the 3 top vendors. What does that mean? That means it's easy for a lot of devices out there to guess what the offset is. So to speak, how to find the Bluetooth address. And I used to have a OnePlus 3, which had a 0 offset from Mac to from Wi-Fi to Bluetooth, which I think is not even legal. Apple usually uses -1, so if you subtract the Bluetooth address from the Wi-Fi address, and Huawei has some odd values here, like -2501, 2001, 3001. So it's like not random, right? These are classes of offsets. Samsung uses -1, but does something ugly I will talk about here. So sometimes devices do have different OUI IDs. So I call this address space entanglements because like the one part, like the Wi-Fi Mac has the left OUI keys. And on the right side, you see the OUI ID of the Bluetooth address. So in some cases, this is not the same address, and I'm not really sure why this is. So maybe this is because of manufacturing logistics, or maybe it's because I usually photographed new devices that were in the shelves just recently. So maybe the manufacturers were just having small batches of productions and were using up like old orphaned MAC addresses there. I don't really know the reason for that, but it happens. It's not the majority, but still you find like these entanglements a lot. So the new task is not to find Bluetooth addresses anymore. The new task is to find Wi-Fi MAC addresses. And usually this is easier. There's known approaches to that. It's Wi-Fi probes sent out by all kinds of devices that you can collect. It's using ARMON next generation, where you can also sniff into encrypted networks to see the MAC addresses being used there. It's by using, or by just connecting to public Wi-Fi hotspots where everybody is able to see everybody else, or by running a rogue access point with a well-known SSID, for example, like Google guest PSK. You could try that. All the devices that know this SSID will connect, and so you will get their MAC address in return. And collecting non-random IP version 6 local link addresses also would work, because these non-randomized versions of these addresses contain also the MAC address of the interface. So there is existing countermeasures against collecting Wi-Fi MAC addresses, and usually you find them in Android devices a lot. So that's what this research is based on. So Android uses, starting with, I think, Lollipop, a certain OUI prefix plus random bytes for doing Wi-Fi probes. And I wrote that out there. So if you find an address like that, you just can ignore that. But it turns out that this probing Mac, so I have to drink here. So this probing Mac was not always in every request back then. So that was a funny observation. I think they got better with this. I don't know what caused the device to use the original address for probing and sometimes this special ID, but well. And there's also randomized MAC addresses. I found that in the developer options of my Android Pie device. So I don't know if this is standard. I'm using a OnePlus device. Not sure if this is something they put in there, but there's also apps out there that would require you to have root on Android that would randomize your MAC address when connecting on a Wi-Fi network. In Q, it's default, you say? Good to know. So for a lot of people, not so much for me. Sometimes in Android devices, there is a deactivation of network interfaces once they're not used. So this is referring to the DOS feature that saves a lot of energy on Android devices. So this is also a kind of mitigation against this issue, but it's right there. And Wi-Fi access points with client isolation would also not work for getting addresses off the, let's say, Google Guest PSK network, because client isolation is active there. I just tried that before. So knowing all this, I came up with the Beast. The Beast is like just a hub with an attached USB armory, which runs Kali Linux and has, I have to mention this, a very high power. You can start a car with that once your battery is empty, because you have peaks. Once you switch on that hub, you will get a lot of current flow, and most battery packs won't be able to provide this kind of energy. So that was the first approach of doing all kinds of scenarios. So what did I do with that? There was like the hybrid method A, I call. It's just scan for LAPs and smartly correlate Wi-Fi probes with these LAPs. So how did I get these LAPs, these Bluetooth-specific lower address parts? I just used an Ubuntu, having it on promiscuous mode, which then would monitor a few of the 79 channels and grab off these lower address parts. And then correlate it timely with the devices that send out MAC requests all the time, and just add these parts together and try out whether there is a device there or not. The downside of this approach is you need specialized hardware, obviously. And both of the devices' interfaces must be communicating for you to see the MAC address of the Wi-Fi interface and to see the lower address part of the Bluetooth interface. And the downside of this method is also you're only able to find devices that have dual, like two kinds of interfaces. Like usually these are smartphones, tablets, laptops, wearables, not so much Bluetooth only devices or like beacons that only use Bluetooth low energy. But it's quite efficient. So hybrid Bluetooth device detection method B is now a very easy approach. So this is based on that list of known offsets that I was presenting earlier. You just scan for Wi-Fi MACs and do the math, kind of. And then you do an educated guess on the BD address and try to connect to it and to ping it and see if it's there. Also, the same downside only works for devices which has Wi-Fi and Bluetooth interfaces. And also, but there's a few upsides to that. You don't need special hardware, so the barrier is very low to start searching for Bluetooth devices with this method. And there's another upside. There's maybe an app for that. More on that later. But you will now say, well, the title says advanced Bluetooth device discovery. And of course, I took this into account. And I've always been curious in that way. So TensorFlow is making that advanced. There's many other things as well. So it's machine learning. And the plan is to have two different models for that. Like one classification model that would, based on the address, tell me, well, there's an offset of 1 or -1 or 2,500. And the other part is for these randomly generated addresses that maybe follow some rule which is more complicated. And that's why I would like to do a regression model on these addresses as well. So my sample size is way too little. I have 220 different devices, which was a lot of work. But I need more data for that, for doing modeling with TensorFlow. And there's this proof of concept app, which I call Peekabooo. And the logo is a cat, and that can't be a coincidence. So go to the Play Store and save the cat. There's many orphan cat copies out there. They give them a home on your phone, please. So it's not yet available in the App Store or in the market, in the Google Play Store. And we see shortly what it does. That's a demo. It's just straightforward. I'm starting the app. And now the app scans for Wi-Fi addresses in the same hotspot. So this could be a public hotspot, or this could be your rogue access point that you brought with you. And now this takes a little longer. It tries to connect on the Bluetooth level. It does a ping of kind of 2 guesses per device. It's like just -1 and +1 for now, because I didn't incorporate a TensorFlow model yet. So, and to keep things interesting, only the last entry on this list is a match. And by the way, it's not easy to do Bluetooth scans with the Android API. It's not meant to be done there. I think this has to do with privacy concerns. It's not even possible to glean this own addresses from the device. Before Android 6, it was possible to get the MAC address from your device. Now you would have to get the link local address of your Wi-Fi interface, the IP version 6, in order to get your own MAC address. And maybe giving things away here, because this is a privacy concern. With this information, apps can identify phones very closely. And to the other hand, the BD address cannot be questioned anymore from the API. So what you see here, you didn't hear it, but it said meow. Yeah. And this is the way how you would teach the system about a new address that is not able to be discovered yet. So I enter here the MAC address, or the Bluetooth device address of my tablet, and it's scanning this single device again, and you see the offset here, something around 196,000. This is a quick walkthrough of the app, so there's not a lot of things to see. I hope you saw the time up there. That was Sunday at 4:13 a.m., so I did work a lot for this app, and all ahead of time, sure. So, but in order to get all this data, I collect from this app. So if you scan devices, I will send information back upon positives that were identified, and also information about the devices that you provided an address. And this data is not personal at all. So it's using randomized MAC addresses. There's usually an offset added to both addresses so that the offset in between those 2 addresses stays the same for the learning. The Bluetooth device name, which often holds the model name, is transmitted. And the offered service IDs. And the offered service IDs are collected for later use. These are usually UUIDs referring to things like OBEX push, like kind of offered services via Bluetooth Classic. And maybe we're bringing back the Trifinite blueprinting project, which was all about identifying models by their Bluetooth properties. And yeah, this is also not personal. It's you have to argue on a GDPR level here, because I'm also collecting the Android advertisement ID, which is kind of unique to your device, but can be changed over the course of time. So this is not personal, but it would help me later on to identify double entries with very similar devices that I can then take out of the sample. And this is what a very minimal version of a rogue access point could look like. So this is an El Cheapo, I think TP, D-Link, whatever, access point that I found one day. It has a Chinese interface only, and you can set it on a name and just power it on with a little power bank and bring it along. So I don't want to give you ideas, but maybe this is a new reason to lurk around like public hotspot places. And see there, we also have our first endorsement for the product. It's from hip people to hip people. You understand? So that's been it. So I want to thank my wife Eva for bearing with me, especially during the last 2 weekends. I want to thank Greenbone Networks, who's helping me to work on the good side of things. And of course, thanks to B-Sides Munich and all of you for making this possible here. So is there questions? Or maybe that's your job, Martin, to ask for questions.
I can get my... So, while I'm waiting for my microphone to work, are there any questions? Hello? Yes, there we go. There's one right over there.
Hi, thanks for the talk. Could you shortly elaborate what you can do if you have the MAC address, the Bluetooth MAC address? Maybe I missed it.
I'm glad you're asking. So I prepared for this question. So the question would be why we collect, or why would somebody collect Bluetooth addresses? I myself do not present an attack here today, but I have a question, FAQ. So why is that? You all are familiar with the underwear gnomes. I think the business model is very similar here. So phase 1 is collect BD address, phase 2, and phase 3 is profit, right? Does that answer your question? Good, I'm happy.
So any other questions? There must be questions. This is a really interesting talk. I would have a question. Because you mentioned that the Wi-Fi system and the Bluetooth system shares the same SoC. Is this all like one big SDR device basically in that SoC, or have you ever looked at that?
Not really, but there is like known manufacturers that kind of bundle all these functionalities. I don't know what the core on these devices is looking like, but I could imagine that there is like crosstalk possible, like on a very low level.
There's a question over there. Michael? These microphones are on Bluetooth, so...
Right. Test. Ah, now it works. So since you prepared for the first question, my second question is, what other questions have you prepared for?
Oh, is that a very good question? I'm glad you're asking. So the other question I prepared for is, why did you use a cat there? So cats are sneaky, and so are you when using Peekaboo. And of course, there's a very famous example of a cat choosing little blue things, and that is Azrael from the Smurfs. So that's the other question. And then, to be honest, I have also here like a list of one too quick. It's there. Something bad happened.
Who's been hacking him?
Yeah, all right. So that was just the bill of materials for the Beast, which is like around 300 euros. There was 2 Bluetooth, Ubertooth dongles, a lot of standard dongles, and that's been it for the Beast. So that was the third question I was prepared. Thanks for the question.
Thank you too.
Any other questions? Really? No more questions. Are you all basically frying here? Oh, there's a question right over here.
Hi. When you have these addresses, can you ping them directly? So if you know the address, normally you have to discover them. If you have them, do you have software to just write them and attack them or something?
Yeah, you can. Of course, if you have the address, the standard way under Linux would have been to do an L2 ping. That required the device to be in pageable mode or to respond to page requests. And there's devices out there. For example, my new car doesn't respond to page requests anymore. So that's a hardening measure that no vendor would consider, I guess, because it's like I have to click here.
Always click.
Always click.
Always click.
I just open up the presentation once more. Okay. So there's nothing more to see except my contact details. So in case you have questions afterwards. So here we go. So, right. So you would have to ping it. This is not possible under Android. You have a very limited possibility to talk to external devices, which is for a reason, I guess. But the good thing is the app doesn't require root access. With root, you would maybe be able to install some kind of binaries on there in order to facilitate a ping as we know it from Linux.
So, if there are no further questions, I would like you to help me by thanking Martin for this wonderful talk about Bluetooth discovery.